Hey, what's going on, everybody? Today, let's learn about Capsule Corporation. No, I'm sorry. I mean inflation. Just kidding. Of course, I mean encapsulation. Without further ado, let's get into it.
Does that encapsulate you?
Okay, let's go ahead and jump right in with encapsulation. I'm going to go ahead and open up my Visual Studio Code, and you'll notice I've already created a file called encapsulation.java. Go ahead and pause this and make sure that you create the class encapsulation and animal, just as I have here, and then return. So go ahead and take a pause and come back. Okay, now that you have all of the code copied down, let's go over what encapsulation is. So the main idea of encapsulation is it is self-contained code. What do I mean by that? Well, if you think of a pill, or a capsule for that matter, everything within it is protected by its shielding that it has on the outside. So what I want you to think of, especially when you see something like a class, the class here is going to be the capsule, where everything inside of the class is what needs protecting. Some things that we might want to protect are this variable and this method. Now, we probably don't want to protect the constructors because the constructors are what allow us to make these objects from the outside. Now, this animal class actually breaks the concept of encapsulation, and I'm going to show you how right now. So let's go ahead and say animal snake equals new animal with a semicolon at the end of it. So now that we have our snake object, if you did the last project, you know how to set a variable from outside of its class. We can simply say snake.name equals, and we'll say Ekans to keep it simple. And now that we have our snake name, let's go ahead and print this. So let's do a system.out.println, and we're going to print snake.name. Let's save this and go ahead and open up a terminal. We're going to change directories to our desktop and our Java folder. And let's compile this. So we're going to say javac encapsulation.java. It compiled successfully. So let's run it now with Java encapsulation. And sure enough, you can see that we got Ekans. So how does this break encapsulation? First, notice when we call snake.name, we're accessing that variable directly and we're setting it equal to something by saying equals here. The reason why that breaks encapsulation is because we're effectively reaching in to that class and saying, hey, we're going to store something in this name. The problem arises with if you have a bad actor, they could make it be whatever they would like it to be at this point, and you could run into a lot of trouble. How can you fix this? Well, remember back in one of our other videos how we talked about public, protected, and private? Well, now we're going to go ahead and utilize the private identifier in front of our string name. If you recall from that video, the way private works is private is going to make this variable only visible to anything within this class. Effectively, the way you can think about this is it's only going to be visible within its capsule if you want to think about encapsulation. So there's some other things that we could do too. So for example, this move function here, we can also make this private as well. So let's go ahead and make this private. And then let's maybe even just try to make it move. So we'll say snake.move. And now let's see what happens when we compile and run this. So if I go and open this up and let's compile, we now get a bunch of errors, and it's going to let us know that name and move are both private. So now that they're private, we can't simply just reach in and make changes the way we want to. So that's going to raise a natural second question. Well, if I wanted to make changes and I wanted to keep it safe, how can I make those changes? So I'm going to introduce two new concepts that are going to allow you to make changes to this in a safe way. So the first one is going to be called what we call a getter. And a getter is simply going to be something that's going to allow you to get the variable's value and return it to whoever's looking for it. In this instance, it has to be public because then if it's not, they won't be able to access it. We want to use the same return type as the variable that we're returning. And then finally, since we're trying to return name, let's say get name. We're going to do open and close brackets, and then we're also going to do open and close parentheses as well. And in between the parentheses, we're not actually going to pass anything because this method is going to pass to whoever is calling it. So here, I'm just going to simply return name. And you might be asking yourself again, hey, what gives? You made this private. Why would I want to be able to return it to someone? Sometimes it's okay to show the value if somebody uses the correct method. And remember, this method can access name because it's within the class. So it's still within its capsule, which is why it'll work. Now, the other thing that we're going to need to set up is what's called a setter. A setter is going to be able to make it so we can actually change the value of a variable, and we could do it in a safe way. So let's go ahead and make it public. It's going to be void as well because we're not actually returning anything. We're setting the value. And then finally, since we're setting the value, we can just say set name, and let's pass in a string n so that way we have the name that we're going to use. And just to set it, it's simply going to be name equals n. And now we have our setter and our getter. So how can we use these? Well, let's go back up to our encapsulation class up here, and let's make a couple of changes. So we're going to keep the object the way we created it, but now let's set our name. So we're going to say snake.setName, and we're going to pass in ekins like so. And now to print it, we do a system.out.println, and let's say snake.getName now. And now our function should work exactly as it did before. So to test this out, let's go ahead and compile and run this. So we're going to go compile and run. And sure enough, we got ekins. So your question now might be, well, it looks like we did exactly the same thing. So it doesn't look very safe to me. What's the benefit of using a setter and a getter here if it's going to do just the same thing as when we did snake.name equals ekins? Well, let's take a look at how you can actually control what people can set with a setter. So let's say now that in the animal class, we didn't want to use dogs as a potential animal. If that was the case, then what we could do is maybe look at what the value is that's being passed in. And if it looks like a dog name, for example, Fido, then we can simply block it from setting the name. So we're going to start with if here, and then we're going to look to see if it's Fido. So we're going to say n.equals, and then we're going to make Fido be what we're going to check for. And if you were wondering why I'm not using equals equals here, it's because since I'm checking a string, we want to use the function .equals because it'll actually check for equality for a string correctly where equals equals might not. Okay, and since we did not want Fido, we have to make sure to put not here because remember, we're checking if it is not equal to Fido. And if it's not equal to Fido, then we can go ahead and set the name to whatever we want. But if it is equal to Fido, then we're going to enter this else block. And let's just do a system.out.println. And we're going to say no dogs allowed. Name was not set. That is going to be a way we can use the setter, but let's actually see this in action. So instead of saying ekins, let's actually pass Fido and see what happens. If everything goes to plan, we should see an error message here that we made print out to the screen. So let's go ahead now and save, and let's compile and run. So we're going to compile and run. And you can see it says, no dogs allowed, name was not set. And when we looked at the value for the name, we got null. And that tells us that it was not set. And just to check to see what happens if it works, let's go ahead and change this back to ekins. We're going to save it. And let's compile and run. And notice now all we get is Ekans. So that is why encapsulation is so important, because it allows you to control the security of what's inside your classes and what's inside your code. So you can see here that this setter is being used to protect against a type that we're not looking for, which is a dog type in this instance. And we're saying, hey, no dogs allowed. Isn't that pretty cool? Okay, so let's move into the last topic that I want to talk about today, and that's variable visibility. So whenever you make a variable at the top of, say, like a class, this is going to be called a global variable. So up here, this is where your global variables are going to go. And let's say we simply had like an integer called age, and let's set it equal to 5. Anything that's in between these curly brackets will be known by the class. The higher the level, the more visible it is. So notice that this only has one indent and it's at the top of the class. It's because of that. That's why this is global. Well, when does it not become global? Well, let's say that we made another function. So let's call a function here. And let's say that this function is simply going to be void do stuff. And inside of do stuff, it's going to do a lot of stuff. So for example, let's go ahead and have void do stuff do a for loop, and let's pass a variable inside of it and see what happens. So we'll say for int I equals 0, I is less than 5, I plus plus. And then I can do something like system.out.println, and let's print out I. Okay, so if I was to call this do stuff inside of my main method here, then it should print out 0 through 4, right? So let's go ahead and do that now. We're going to go ahead and make our encapsulation object. So I'm just going to say encapsulation e equals new encapsulation. And then let's just simply say e dot do stuff. Okay, let's go ahead and compile and run this and see what happens. So if I go and compile and then I run, you can see that we get 0 through 4, just as expected. What if we put this int age equals 5 here, though? So if we put the 5 where the I goes, it should just print 5 repeatedly until it hits 4, right? And I know that might be confusing, so let me clarify. When I counts up from here, from 0 to 4, it'll print 5 on every single one. So let's run this and see exactly what I'm talking about. And you can see that we get 5. The reason why we're able to get 5 is because, remember, the higher the level, the more visible it is. So what would happen if I were to create a variable here called string name equals dog? And then outside of this for loop, I went and said system.out.println dog. What do you think is going to happen here? Is it going to go ahead and print dog? Well, let's find out. If I go ahead and run this, compile, notice I have an error and it says cannot find symbol, the variable dog. Why can't it find it? Remember the key point that I said with this int age equals 5. The higher the level, the more visible it is. So notice that the indent here on the string name dog is within this for loop. Since it's inside this for loop, it's only visible between these brackets right here. But it is not visible between these brackets right here. If I were to change this, so like if I wanted to fix this so it would actually print, what I could do is take this out of the for loop and then drop it right above. And notice now that dog is between these two purple curly brackets. It's no longer between the blue curly brackets. So what's going to happen here? Do you think, is it going to print dog? Is it going to print 55555 dog? Well, let's find out. If I go ahead now and let's try to compile and run this. So we're going to say Java C. We get an error and it says that it cannot find dog. And that's just simply because I made a typo. I made this say name and that's dog there. So let's go ahead now and change this to name. And now let's compile and run it. Compile and run. And you can see we get 55555 dog. So just to show you that it wouldn't have worked before, let's go ahead and put this back to where it was inside of the blue brackets. And now let's try to run this again. And we should get an error. And we do. Notice that it still says it cannot find the variable name. And that's because, remember, it's not on a high enough level. Here, it's within the two blue curly brackets of the for loop. And then the purple one here is on the outside. It's on a higher level. Therefore, it can't see it because it can't look down and see it from the inside. It can only see it outside. And to kind of tie this all back up to encapsulation, if you think of this little blue curly bracket as a capsule, it's going to be pretty hard to see inside of it, right? This age is going to be visible to everything within the class simply because it's at the highest level. It's between the two gold curly brackets here between line 17 and line 1. But any other variable that you define, the deeper that you define it, the harder it is to see. And that's actually a fantastic point when it comes to security. So let's say you had a variable that you really needed to make sure was private and hard to find. Well, put it at the lowest level that it needs to be defined. Don't make everything global, because making everything global will make it more insecure and more easy for everything to see. But if you actually hide it in here and just know that if you wanted to print this, that you would only have to move the print statement into its domain where it's visible, then if we ran this, we should probably see something like 5 dog 5 dog 5. So if I ran this now, compile and run, you can see 5 dog 5 dog 5 dog 5 dog 5 dogs 5 times. But that is kind of the point of encapsulation. So it's definitely a tricky subject to wrap your head around, but to kind of summarize, remember, the curly brackets are effectively capsules. The higher you are whenever you declare something, the more visible it is. And if you would like to protect the structure of encapsulation, you're going to want to use the private identifier in front of the variable. And finally, if you want to control how people see the variable, you can set up a getter and a setter that makes it visible exactly how you want it to be visible. And that's all for today. I hope you enjoyed this, but for now, I'm going to go ahead and kick it back to Dino in the future. Thank you for watching this video. I hope you learned a lot about encapsulation today. It might take a little bit of practice.
We sitting here, I'm supposed to be the franchise player, and we're in here talking about practice.
Thank you, Allen Iverson. But if you take the time and learn encapsulation, it's really not all too bad. I hope I was able to make that a little easier for you. But other than that, I am DB, you are you. Let's keep rocking, and I gotcha. But let's keep learning. Thanks, everybody. Peace out.